Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. So that gives us our understanding of how our networks are supposed to grow. So we actually have several different WAN operation standards. So the governing groups are things like IATIA, ISO, and IEEE. WAN technology normally operates at two different layers, layer 1 and layer 2. At layer 1, we're looking at things like SDH or SONET or some form of DWDM or wavelength multiplexing. Or we could be looking at different layer 2 technologies, broadband, wireless, Metro E, MPLS. Those are the big ones. HDLC, frame relay, ATM, those are all older legacy technology. Metro E, Ethernet, MPLS, those are the more common layer 2 WAN connections. Some terminology is extremely important when we're discussing our WAN. First of all, let me grab my pen. This guy right here, this junction box. This junction box, also called the demarc point, is the location, the physical location where the service provider comes in, and that is the end of their responsibility. So from that junction box back to the company, that's the service edge provider, SPE. From that junction box into the business, that is the enterprise edge. Sometimes it's also called the customer premise equipment edge. And that is actually going to make up the equipment that allows for the interconnectivity between the service provider and the enterprise network. We will have a few other pieces of equipment. We may have a DCE, and that's going to be a data communication equipment. That could be a switch. That could be some form of other equipment that's giving us our handoff. What I've seen in this location is I will see maybe a fiber line coming in. The fiber line will plug into the switch, and then the switch will transform that fiber connection into a Ethernet handoff, and they feed that Ethernet into the router. And in that example, the router would be known as the data terminal equipment. That is what will allow us connectivity to our LAN. So this would be to our LAN. On the service provider's side, this is known as the local loop. The connection between the demarc and the junction box in the neighborhood or in that area is also called the last mile, and it's typically about a mile or shorter. Those connections will go back to some type of central office, CO, and our CO will actually have a CO-based switch. From there, our central office will connect to their service provider to provide internet. So we talked about our demarc, we talked about our customer premise equipment, we talked about our DCE, we talked about our DTEs. What about this point of presence? Again, this is where the point where the subscriber network connects to the service provider. Our demarc is also sometimes called the POP, or point of presence. And we're not done with our terminologies. We've already talked about our local loop, also known as the last mile. We talked about the CO. So we also have things like our toll network. These are typically long haul backbones. These are typically WAN provider connections, and this is going to be normally a high bandwidth, and this will connect our COs back to the service provider. Our backhaul network, same thing. They may connect multiple COs. And our backbone network, again, a large high capacity network used to interconnect multiple service providers. That provides us enough of the terminology that we need to at least examine our different WAN technology. However, because we've also started talking about customers, we have to look at, we may have a voice modem, which is still legacy. We could have some type of DSL or cable modem, broadband. Those are going to be our DTE type connections. If we are using a leased line, for example, we may have a CSU, DSU. Realistically, these aren't used as often anymore because leased lines are expensive and the bandwidth isn't really there. An optical converter could be something that will convert an optical cable to a copper cable. We've seen that in the previous slides as some form of DCE. And again, that's where we would take our optical cable and convert it to a copper-based cable, or vice versa. We could have some form of wireless connectivity, a wireless access point, a wireless network, a wireless connectivity for our WAN. It really depends. And lastly, we have our WAN core devices. This is going to be our layer 3 devices that run our core for our connectivity. And again, this is typically from the service provider's level. So this core is going to be the service provider, not the individual business provider. So that leads us into how we do our basic communication. Our communication normally is done one of two ways: serial or parallel. Serial is one connection, parallel is multiple connections. Almost all network communication is using a serial connection delivering. The serial connection will transmit bits sequentially over a single channel. Again, in contrast, parallel will simultaneously transmit several bits using multiple wires. As the cable length increases, the synchronization time between the different mediums or the different channels become more sensitive to the distance. That's for this reason parallel communication is very limited to short distances. Most things still use serial connectivity. Some of our older WAN technologies are things like our circuit switching. That's going to be our old telephone systems or our ISDN lines. This will use circuit switch networks. They will establish dedicated circuits or channels between our endpoints through the network and to the end device using circuit switch technology. However, modern day technology will use what's known as a packet switch communication or packet switch topology. And this can change. Each packet can actually go a different path. They will segment traffic into multiple packets and they will use a shared network. It's less expensive, way more flexible, and again, common types of the packet technology is going to be things like Metro E, MPLS, or older technologies like frame relay or ATMs. This is the common, more modern way of doing communication over a WAN technology. Most ISPs will use some form of packet switching technology. So earlier we said our layer 1 technology is things like SDH or SUNET or some type of dense wavelength division multiplexing. That is where the layer 1 functionality comes into play. And this is normally when we're talking fiber, because SDH and our SONET are all fiber. Where dense wavelength division multiplexing, it's a newer technology that increases data carrying capacity of both SDH and SONET by simultaneously sending multiple streams of data, multiplexing the wavelength to send over one of their platforms. SDH is synchronous digital hierarchy. It's a global standard for transporting data over fiber optic. SONET, again, synchronous optical networks, and this is used in the US, and it provides the same service as SDH. And again, our DWDM is just a newer version of our SDH. Moving on, we have our traditional WAN connectivity. Those traditional WAN connectivities are going to be things like dedicated leased lines like T1, T3, or we may have a switch network, either circuit or packet switched. Again, legacy are going to be like plain telephone services, ISDN, frame relay. This is all older technology. And this is when LANs appeared in the early 80s, early 90s. And what needed to happen was their networks needed to have a local connectivity to a service provider. And they needed dedicated leased lines. And so this was the traditional way to provide connectivity. Now keep in mind, a T1 is 1.54 megabits per second synchronous, up and down. Realistically, that's not feasible anymore. You can this was also like $800, $900 a month. That doesn't really fly anymore when you can have broadband technology that is 100 times the speed or 300 times the speed for a third of the costs. So again, there's pros and cons for some of this older technology. Lease lines are available in different fixed capacities. A T1 is 1.544. A T3 is a bundled set of T1s, and you can have that up to 43.7 megabits per second. European carriers use the E series, and that's going to be 2.048 megabits or a 34.368 megabits. However, some of the advantages, very simplistic, the quality was there and the availability was guaranteed. Again, negative is the cost, and it is not very flexible. With our circuit switch options, again, PSTN based networks are our plain old dial-up or old technology phone services, and they were 56K. We had our integrated service digital networks, ISDNs, and again, this was built off our 56K, and this was providing speeds of up to 2 megabits per second. These kind of went away early 2000s. Packet switching technology in our early network designs were frame relay and ATM. Frame relay is a simple layer 2 non-broadcast multi-access network, where with ATM this was an asynchronous transferred mode, and this used cells instead of packets, and they did fixed length cells of up to 53 bytes per cell. So again, very low speed, but these are a legacy and these worked. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.